This is mathheals.com, where you can find more links to math YouTube videos and computer science. In this lesson, we're going to take a look at the hyperbola. That should be all together. no space there. Okay, that's going to bother me. So hyperbola. And that's where you have a graph that looks, assuming I could draw it a little bit better, looks like this. And then one over here looks like this. And we'll hopefully see a little bit better pictures of this than what I'm showing. Now, if I look at the hyperbola, we're going to have, well, we'll have other pieces too, but these are the ones I want to specifically talk about. We're going to have foci. We'll have a focus here and a focus here. So foci, plural. And if I look at any point on my graph, this right here, this distance here and this distance here, if I subtract those, the difference between them, between this one, let's say this is, I don't know, D1, and this is D2. So if I subtract them, then it's going to equal to plus or minus 2a. Of course, the plus or minus depends upon which one you subtract from which. D2 minus D1 will give you a negative. Still be the same value, but just be a negative version of it. And we won't do a whole lot with the foci. That kind of is the major defining point of a hyperbola. But it really doesn't help us much in terms of coming up with the graph. Well, let's take a look at our formulas. We got two standard forms of the hyperbola. Make that a little bit bigger. One of them is where the square root is on the x, and then we have a minus, and then square root is on the y. And the other one is where we have square root on y minus a square root on the x. There's always a minus in the middle. And on this first form, your x squared is before the minus. And this one, the y squared, is before the minus. And then we got x minus h. H is just a number. You could be a plus there. It could be x plus 3. But you got x plus or minus a number. You got y plus or minus a number. And both of them are squared. And then they're over numbers squared. A and b are just numbers. And then you have to have a 1 on the right side. This one is very similar, except it's kind of flipped around. Y minus k squared and x minus h squared. And a and b. And 1. And b squared is equal to c squared minus a squared. The center on both of them are hk. For a formula on the left side, our transverse axis. Transverse axis is what would go through like this. That's our transverse axis. That helps you to, boy, let me go back to my writing class. Try it again. Transverse. That's better. Not perfect, but better than that. That's our transverse axis. Kind of helps you to see how it opens, whether it opens to the left and to the right, or up and down. Okay. For the formula on the left, transverse axis is parallel to the x-axis, and this one's parallel to the y-axis. For this one here, foci is h plus c, comma k, h minus c, comma k. Vertices are h plus a, comma k, and h minus a, comma k. And our asymptote is y minus k is equal to plus or minus b over a, x minus h. For this one, of course, our transverse axis is parallel to the y-axis. Foci is h, k plus c, and h, k minus c. And vertices are h, k plus a, and h, k minus a. And asymptotes, y minus k is equal to plus or minus a over b times x minus h. Let's take a look at our first problem. Then we'll talk about what some of these pieces are once we find it. Okay, we got x squared over 9 minus y squared equal 1. Well, I want them both to be in fraction form. That's easy. You can always create a fraction by putting it over 1. Now, if I compare this against my forms, of course the minus is in the middle, the 1's over here, so that's all good. Our x squared is before the minus. So x squared before the minus is the formula on the left. So those ones we're going to be looking at. Now we want to rewrite this as x plus or minus a number. Well, if you just have an x there, you can always put a 0. So we'll put x minus 0 squared. We want to rewrite this as something squared. Well, that'd be 3 squared. Minus, and again, we can always put a 0 there. And something squared, well, 1 squared gives you 1, like that. So that matches our form now. We're dealing with 1 on the left. Our h is what's with our x. It's going to be opposite sign. Now 0 doesn't have a sign, so that doesn't matter yet. Later on we'll see some problems where that doesn't matter. K is what's with our y. And it's also opposite sign, though 0 doesn't have a sign, so it doesn't matter in this one. The number underneath the x squared part is a in the left form, so a is 3. And the number underneath our y squared part is b, so b is 1. Okay, so we got a is equal to 3, b is equal to 1. We need to find c. Once you have those 5 items, you can find everything. Our formula is b squared is equal to c squared minus a squared. Well, b squared was 1, so we got 1 squared is equal to c squared minus a squared. A is 3, so we got 3 squared. So we got 1 is equal to c squared minus 9. Take the negative 9 over, becomes a positive 9. And we get c squared is equal to 10, or c is equal to square root of 10. Now you want a, b, and c to always be positive. Fits better with the formulas I gave you. A is 3, b is 1, and c is square root of 10. And h is 0, and k is 0. So those are our 5 items we need for all of our formulas. So let's find them. Center is hk. Well, that'd be 0, 0. If I were to draw the center on this graph right here, our center is right here. Okay, transverse axis. Says it's parallel to the x-axis. So parallel to the x-axis. Well, here's the x-axis. So parallel to this means the transverse axis. Don't know where it'll be. Actually, I do on this one, but let's pretend I don't know where it's going to be. Parallel means it goes like this, which means my graph's going to look like that. So that piece of information right there tells you a lot about what this graph's going to look like. Okay, foci. H plus c k and h minus c k. Well, just double checking my formula. Okay, h is 0 plus square root of 10, comma k, which is 0, and 0 minus square root of 10, 0. So our foci is square root of 10, 0, and negative square root of 10, 0. Now, next thing is our vertices. Vertices. What in the world's a vertice? This right here and this right here is our vertices. Okay. Well, our vertices are h plus a, k, and h minus a, k. Again, we're dealing with the formula on the left side here. H plus a, k, h minus a, k. 0 plus 3, 0. 0 minus 3, 0. So I get 3, 0, and I got negative 3, 0. Our asymptotes. The vertices and asymptote and the center, I think, are the important pieces. We've got y minus k is equal to plus or minus b over a x minus h. Well, we said k was 0. Goes plus or minus. B we said was 1. A we said was 3. And x minus h, which was 0. So our asymptotes are going to be y is equal to plus or minus 1/3 x. Those zeros drop away. Let's graph this now and see what in the world all these pieces give us. Center was at 0, 0. That's what we found right here. Of course, we know what our graph looks like from the transverse axis. Foci we're really not going to use. Vertices, 3, 0, negative 3, 0. Again, knowing the way my graph looks, I already have a pretty good idea of it. Our asymptote, very important in helping us get the shape of it. Not everything, but helps give us an idea. Now, this is if I were to put this in slope-intercept form, this would be y is equal to plus or minus 1/3 x plus 0, which means my y-intercept is at 0, which is the origin. Our slope is 1 over 3, changing y over changing x. So I'll go up 1, and I'll go right 3. And that's where I'd have a second point. So our asymptotes, there's one of them. Now our other one is a negative 1/3 x. Well, if my slope was negative 1/3, then I'd go down 1 and right 3. So it'd be about right here. By symmetry, you could do that without doing that. So those are my, assuming I could draw a straight line. That's pretty pitiful. I haven't been drinking, honest. Those are asymptotes. Okay, so an asymptote, your graph's going to skim at some point. Now, I don't know when to start skimming. At that part, maybe I have to plug in points to get a better feel for it. But let's just pretend looks like this. This is just sketching. We're trying to get an idea. And I expect that's probably not too far off, actually. But that would be our graph. Again, the important part, center is kind of important because that kind of gives you where the asymptotes pass through. But the vertices are an important part, and the asymptotes are the important part. So let me save that. And trig. H01.pdf. Okay, let's look at our next problem. It says find the equation for each hyperbola, graph the equation. Center 0, 0. Our focus is negative 5, 0. Our vertex is 4, 0. Okay. Let's go back to our formulas. As I look at the focus and vertex, I notice the y parts are the same. Let's look over here. Focus, vertex. KK, the y parts are the same here. On the formula on the right side, the x parts are the same. They're both h. So that's going to tell us which one to use. Since the y parts are the same, we're going to use the formula on the left side. Now, formula on the left side. Center is HK. So that means that this is H, and this is K. Now, our goal is to get those 5 letters. If we have those, we have everything. Our focus is H plus C or H minus C, comma K. Well, we already know K. So this right here is either going to be H plus C or H minus C. I'm going to try H minus C. Now, just because it's negative does not mean that I'm always going to use a minus, because depending upon where the center is, everything could be negative. So keep that in mind. Try one and see if it works. If it doesn't work, it's the other one. When I say see if it works, your C should be positive. Well, we said 0 H was equal to 0, so I'll plug that in. 0 minus C is equal to negative 5. So we got negative C is equal to negative 5. Divide both sides by negative 1, and we get C is equal to 5. So that was the right one. Okay, so we got H, we got K, we got C. Let's see what the vertex gives us. Vertex is H plus A or H minus A. I'm going to try H plus A here. So that's H plus A. Now the y part is K. Well, we already got K, so don't worry about it. Now H we said was 0, so we got 0 plus A is equal to 4, or A is equal to 4. Again, we want A, B, and C to be positive, so we picked the right one. Even if you picked the wrong one, you could flip the sign real easy. Now to find B, we have this formula. B squared is equal to C squared minus A squared. Well, C is 5, so we got 5 squared minus A, which is 4 squared. Which is 25 minus 16. Gives us 9, so B is equal to square root of 9, or 3. Okay. So now we have A is 4, B is 3, C is 5, H is 0, and K is 0. I think they were asking us to find equation. Well, we're doing the formulas on the left, so this is what it looks like. So we got x minus h squared over a squared minus y minus k squared over b squared is equal to 1. That's just our equation. Let's plug in what we got now. H is 0. So we got x minus 0 squared over a squared, so 4 squared, minus y minus k squared, so y minus 0 squared, over b squared, which is 3, so 3 squared, equals 1. So our equation is going to be x squared over 16 minus y squared over 9 equals 1. Okay, well, we're given some information, and from that we can find some missing information and then get the rest. So let's do our graph right here, I guess. I think we said the center was 0, 0, 0. Center is 0, 0. A vertex is 4, 0. 4, 0. Well, center is exactly in the middle of the vertices, so if this one is 4, 0, the other one is going to be negative 4, 0. So I kind of have an idea what it's going to look like. If I had my asymptotes, I would have everything at this point. Well, let's look at our formula for the asymptotes. It's this bottom one. So we got y minus k is equal to plus or minus b over a times x minus h. That's the formula. Now let's plug in what we're given. I think we said that k is 0. So we got y minus 0 is equal to plus or minus b, which was 3, over a, which is 4, times x minus h, which is 0. So we're going to have y is equal to plus or minus 3/4 x for our asymptotes. Now again, if I were to put this in slope-intercept form, I'd have a plus 0 here, so our y-intercept is going to be 0. Then I'm going to go up 3, right 4. 2, 3. Because our slope is 3/4, and changing y over changing x. So up 3, right 4. And it'd be right there. And that would be one of our asymptotes. Now our other slope, these are two lines here, by the way, the plus or minus, means you got y is equal to 3/4 x and y is equal to negative 3/4 x. It would be negative 3, which is down 3, right 4. So down 3. Help if I made this a little bit more precise, but that's okay. You get the idea. And right 4 would be right here. Not that I can't draw a straight line, but those are asymptotes. So our graph is going to come and skim those. There should be symmetry there. This flipped over should land exactly on this. So obviously I don't got it perfect, but this is just a rough sketch. And that'd be your answer. Save this. Okay, let's look at problem number 3. Actually, let me grab a drink first here. Okay. Got vertices. Got negative 6, 0. And we got 6, 0. And asymptote. I'm going to get my writing better if it kills me. It's just laziness. I know how to make letters so they look good. Asymptote y is equal to 3x. Okay. Well, which formula we're going to use? That's maybe a little harder. Not too difficult. But if I come down here, our asymptotes basically the same. So that tells us nothing. Can't look at this and tell anything about that, which formula. But here, let's take a look at this. Vertices. KK, HH. So here the y parts are the same. Here the x parts are the same. Well, my y parts are the same here. So I'm looking at the formula on the left again. Okay, so formula on the left, h plus a comma k and h minus a comma k. I'm going to guess that the negative is our minus. So we got h minus a is equal to negative 6, and this one I'll do as my h plus a is equal to positive 6. Now the 0 is our k. Again, we want to find those 5 pieces of information, the A, B, C, H, K. So I got 2 equations here. I can actually put them on top of each other. H minus A is equal to negative 6, and H plus A is equal to positive 6. And we can use the addition method, elimination method to solve this. H plus H is 2H. Negative A plus A drops away. Negative 6 plus 6 is 0. Divide both sides by 2, and we get H is equal to 0. Well, if we know H, we can plug that back in one of these equations and find the A. So let's do that. So we got H plus A is equal to 6. Said H is 0. So 0 plus A is equal to 6, or A is equal to 6. Closer, we got to find B and C, and then we have it. Our asymptote now. Let's come over to this. We said we're dealing with the formula on the left side, so it matches this formula. So it matches y minus k is equal to plus or minus b over, well, obviously this is the plus version of that, so let me get rid of that, just do the plus version. So b over a times x minus h. Well, we already said h and k are 0, so I can drop those. So this is y is equal to b over ax. Well, if I match this up, then it's obvious that b over a is equal to 3. But we've already found a. A was 6. So we got b over 6 equals 3. Multiply both sides by 6. And we get b is equal to 18. Let me do some arrows to show the flow here. Kind of all over the place there, but it's logical what we're doing. Okay, the last thing we need is c. Got a formula for that. B squared is equal to c squared minus a squared. Well, b was 18, so we got 18 squared is equal to c squared minus a, which was 6 squared. Get my calculator here. 18 squared is 324. So 324 is equal to c squared minus 6 squared is 36. Take 36 over. And it becomes a positive 36. 360. Well, that seems nasty. Is that right? B is that. Okay. A is that. 324. Yeah. Well, drop the squared. Put a square root around the other side. Nobody says it's going to be nice. And this is 36, 36 times 10, so that gives us 6 square root of 10. And those are our items. Now our goal is to find the equation and then graph it. So let me write these down. A is 6, B we said was 18, C is equal to 6 square root of 10, H is 0, and K was 0. Well, we said that we're dealing with a formula on the left side. Well, formula on the left side looks like this. So I'm going to have x minus h squared over a squared minus y minus k squared over b squared is equal to 1. So let's plug in what we found. We said h was 0. So we got x minus 0 squared over a squared, 6 squared, minus y minus k squared over b squared equals 1. Well, this gives us x squared over 36 minus y squared over 324 equals 1. And that's our equation. Well, let's come up with our graph. We're given the vertices and the asymptote. Both of those are the important part. So come down here. One, two, three, 4, 5, 6. And negative 6. 2, 3, 4, 5, 6. Those are our vertices. Our center is halfway in between those, so I don't even need to plug in the formulas. I know it's there. And our asymptote was y is equal to 3x. Well, that's like y is equal to 3 over 1x plus 0. So no surprise, it crosses through the center. It has to. That's by definition. So we're use this to get our second point. So up 3, right 1. So up 3. Boy, that's pretty that's pretty out there. Of course, when I make up numbers, sometimes I come up with weird results, but like that. And then our other version of that would be y is equal to negative 3x. So we'd have y is equal to negative 3 over 1x plus 0. Which means I'd go down 3, right 1. right there. And sloppy. Meant to be in blue too. There. Oops. Didn't mean to eliminate my y-axis. Okay. Try it again. Like that. Goes up like this. And obviously it's not going to skim it right away. You know, it'll probably be up here before it does it, and then down to here. And same over here. That's my best guess without plotting some points, based upon the given information. And probably the reason why it looks like that is because the difference between this large number here, the 324 and 36. Now I haven't graphed enough of these with playing with different numbers to be any kind of expert on that. But if I had to hazard a guess, that's why. So let me save this. Of course, there's always the other thing where I might have made a math mistake. I don't always add and subtract and multi-correct in these videos. So that's my warning on that. Okay, let's look at our next one. Number 4. It says, find the center, transverse axis, vertices, foci, and asymptotes, graph each equation. So we'll go ahead and find everything and graph it. Y squared over 9 minus x squared over 4 is equal to 1. Okay. First off, let's look at our formulas. Squared is on the y before the minus. Squared is on y before the minus. It fits our one on the right. So that's one we're going to be taking a look at. Well, let's put this in standard form first. Standard form says you want this as y plus or minus a number, or this is x plus or minus a number. Again, if you just have single variables like that, it's always a minus 0 or plus 0. We want this as something squared, so that'd be 3 squared. And again, that's x minus 0. We want this as something squared, which would be 2 squared, like that. Okay, from our formula, the k is what's with our y. It's opposite sign. Though 0 still doesn't have a sign. We'll eventually get to problems dealing with that. And this is our h, and it's opposite sign. So h is 0. The a is underneath the y part, so a is 3. And this is b. And b is 2. Okay, well, we need our c, and then we have our 5 numbers. Well, our formula says b squared is equal to c squared minus a squared. B we said was 2, so I got 2 squared is equal to c squared minus 3 squared. So 4 is equal to c squared minus 9. Take the negative 9 over, becomes a positive 9. And we get c squared is equal to 13, or c is equal to the square root of 13. So let me write down what we have. So we found A, we found B, we found C, found what H is, we found what K is. Okay, so let's find our various pieces of information. Keep in mind the formula we want is the one on the right side. So our center is HK. Which would be 0, 0. Now our transverse axis, parallel to the y-axis. Transverse axis. Parallel to the y-axis. Well, what does that mean? Not for this one, because this one passes through the origin, but Parallel to the y-axis means it's up and down like this, which is usually of the form y is equal to a number. Usually. It always is of that form. And the transverse axis is always going to pass through your center. So our transverse axis is going to be y equals whatever the y part of your center is, which is, in this case, 0. So that's our transverse axis. And right away I know, because of the way it's going like that my graph's going to look like that. So that's very useful. Foci. Our foci is hk plus c and hk minus c. Well, h we said was 0, k is 0, plus square root of 13, and this one is 0, 0 minus square root of 13. So we'll have 0 square root of 13, and we'll have 0 negative square root of 13. Okay, our vertices will be h, k plus a, and h, k minus a. So our formula right here. So we got 0, and then 0 plus a. A was 3. And then we got 0, 0 minus 3. So we got 0, 3, and we got 0, negative 3. Okay, our center is 0, 0. So we're sitting right there. Vertices are 0, 3. So that's one of our vertices. And negative 3, or 0, negative 3. That's another vertice. So I know it's going to go like that. Well, let's find our asymptotes. That'll help us maybe get a little clearer picture. Formula for that, we're dealing with one on the right side here. So we've got y minus k is equal to plus or minus a over b times x minus h. A over b, x minus h. Well, k is 0. Equals plus or minus a. What was a? A is 3. So we got 3 over 2. And then x minus h, which is 0. So our asymptotes are y is equal to plus or minus 3/2 x. Okay. First one. Y is equal to positive 3/2 x plus 0. And then our other one is y is equal to negative 3/2 x plus 0. Well, 0 is our intercept. So it passes through this, which it has to go through your center. So, I mean, that's no surprise. Slope is 3/2, so changing y over changing x. So I go up 3, right 2. Right there. And draw a line that goes through them. Like that. My other one, changing y over changing x. So I go down 3, right 2. So down 3, right 2. And this would be our other asymptote, assuming I could draw a straight line. There we go. Close as I'm going to get. Okay, so then graph's going to go something like this. I'd have to plot points to get any more kind of precision than what you're seeing here. But that's our rough sketch. Save that. Let's look at our next problem. Okay, I got 3x squared minus y squared equals to 9. And let me grab a drink before I do this one. Okay, let's go look at our formulas. One major feature of these formulas, you have to have a 1 on the right side. So first thing I'm going to do is divide everything by 9. So I got 3x squared divided by 9 minus y squared divided by 9 equals 9 divided by 9, which gives us x squared over 3 minus y squared over 9 equals 1. Okay, now that I got a 1 there, I notice I got my minus here, which that has to be between them, and our x squared is before the minus. Here's the minus. X squared is before the minus is the formula on the left side. So we're going to be working with the left. I want to write this in standard form first. So I'll rewrite this as x minus 0 squared over, I want to rewrite that as something squared. You can always put a square root around it, because if I were to go backwards, square root and the second power cancel each other and just give you the 3. Minus y minus 0 squared. Rewrite this as something squared, and that one's easy. 3 squared gives you 9 equals 1. Well, let's identify what that gives us then. Deal with the formula on the left. So h is what goes with x. It's opposite sign. We're still doing zeros, though. This is k, and its opposite sign, so that'd be 0. This is our a. So a is square root of 3, and this is our b. So b is 3. Well, we need to find c. Then we'll have our five variables, 5 letters. So we got b squared equals c squared minus a squared. b is 3, so we got 3 squared equals c squared minus square root of 3 squared. So we got 9 is equal to c squared minus 3. Take the negative 3 over. We got 9 plus 3 is equal to c squared. C squared is equal to 12, or c is equal to square root of 12, which is 2 square root of 3. Okay. Write down everything we have. Now I'm gonna do something practical with the square root of 3, so I want to see what in the world that's equal to. It's 1 point something. 1.7. So approximately 1.7. B is 3. C is equal to 2 square root of 3. We'll use C for our foci, and I'm not going to do anything practical with it, so I'm not going to worry about it. H is 0 and K is 0. Okay. And which formulas we're dealing with? We're dealing with the ones on the left. Okay, so our center is HK. It's always HK in that. It doesn't matter left side or right side. Transverse axis. You know, I don't even think I read the instructions to see what in the world they're asking for. Let me go down. Okay, find the center, transverse axis, vertices, foci, asymptotes, graph it. So do everything. I was going to do that, but okay. So this is parallel to the x-axis. Okay, here's the x-axis. Parallel to it would be something like that, which is of the form y is equal to a number. I'm trying to think. Did I do that right on the last one? Oh, look, because that's going to bother me. Transverse axis. That should be x equals a number. Scratch this off in your notes. Instead of y equals 0, it should be x equals 0. I'm going senile. I knew that when I looked at this one. That one didn't feel right. Go back to elementary algebra. If not pre-algebra for that. Okay. Quit beating myself up. I know there's no way this is going to be perfect unless I read them off of a script, and I'm not going to do that. It takes fun out of it. Now I'm dealing with formula on the left. Okay. Parallel to the x-axis. So it looks like that's y equals. So this is going to be y is equal to, and it passes through the center, so it has to be y is equal to the y part. So y is equal to 0. So I know my graph's going to look like that right there. So that's an important piece. Foci. Check myself in a nursing home this afternoon. H plus CK. I would redo the video, but I'd make another mistake somewhere in there. I'm not perfect. H plus C, H minus C. Okay, focus so you don't make another screw up. Okay, 0 plus 2 square root of 3 and 0, once we plug in the numbers, and 0 minus 2 square root of 3 and 0. So we're going to have 2 square root of 3, 0, and negative 2 square root of 3, 0. By the way, the graph on that previous one was right, but just how I wrote it was wrong for the transverse axis. Okay, we're not going to do anything with the foci. Our vertices. We're going to have H plus A, K, and H minus A, K. That's our formulas right here. So we're going to have 0, what's A? Square root of 3, 0. And 0 minus square root of 3, 0. So we're going to have square root of 3, 0. We'll have negative square root of 3, 0. For graphing purposes, that's almost useless. So I'm going to use 1.70 and negative 1.70. Center is at 0, 0, right here. And our vertices are 1.70. So 1.70, maybe be right there. And negative 1.7, maybe right there. Those are our two vertices. Okay, let's find our asymptotes. Let's see, formula on the left. So, left one. We've got y minus k is equal to plus or minus b over a x minus h. That's just this formula right here. So y minus 0 is equal to plus or minus, have no clue what b and a are. B, 3 and a is square root of 3. So 3 over square root of 3. X minus h. So those zeros drop away. We got y is equal to plus or minus 3 over square root of 3x. Well, that's really nice for precise purposes. It does nothing for us in terms of graphing, though. Let's put the decimal in there. So that means we're going to have 3 over 1.7 x plus 0, and we'll have y is equal to negative 3 over 1.7 x plus 0. Putting them in slope-intercept form. Okay, so this says that it's going to pass through the origin. That's our y-intercept. Up 3. So up 3 and right 1.7. So up 3, right 1.7 would be right there. Pretty soon you'll get see patterns these to help you. So yeah, that's straight above that. This one's negative 3. Negative 3 and over 1.7. Be right there. And assuming I can draw a straight line. Look like that. So this will look, how soon does it skim your asymptote? I don't know. That's a rough sketch, though. Let me save that. I had one semester where I kept saying the word asymptote, and had one student, she just broke up constantly on it. Easily amused. those up every now and then. Okay, let's look at problem number 6. Grab a drink here. I'll find the equation for the hyperbola described, graph the equation. We're given the vertices, we're given the asymptote, so this will be pretty easy to graph with those information. Okay, so number 6. We got vertices, -3, 6, and -3, -2. And our asymptote is y minus 2 is equal to 4/5 times x plus 3. Okay, let's look at our vertices first. Go look at our formulas. As I look at my vertices, I notice the x parts are the same. So x parts are the same. Vertices here, h, h. The x parts are the same. Over here, the y parts are the same for the vertices. So we're using the formula on the right side. Okay, so vertices, h, k plus a. So this is going to be our h. So h is -3. Now k plus a, and then which one of the deal right? K plus a and k minus a. Well, when it's no longer your center's 0, 0, you can't necessarily say which one's which, but it's probably a pretty good guess that this positive one here, since it's greater than this one, will be my h or my k plus a. So I'm going to set it equal to that. K plus a is equal to 6, and this one, k minus a, is equal to -2. Well, let's this is a system of equations. Let's put them on top of each other. K plus a is equal to 6, and k minus a is equal to -2. Well, k plus k is 2k. A minus a drops away, equals 6 minus 2 is 4. Divide both sides by 2, and you get k is equal to 2. Now you might be looking at this like, well, that's obvious. Look at this. Why are you even working that hard? Why don't you just get it off of this? You can't always go off of this. Now, if they came back and said this was strictly the proper form, then you could. But just because it looks like this doesn't mean this is. You can easily identify what the items are here. I could rewrite this an infinite different ways. I could rewrite this as y minus 5. And these were different numbers over here. So that means nothing. Okay. Well, we can get a now. So I'll plug the k equals 2 back in here. So I'll do it right here. Doesn't matter which one you plug it into. I'll plug it into the k plus a is equal to 6. So we got 2 plus a is equal to 6. Take the 2 over, and we got a is equal to 6 minus 2, or a is equal to 4. And again, you're looking at that. Well, that's obvious. Look over here. You had a on top. Again, you can't assume that. Now, we're dealing with the formula on the right. Since it does match now, since this is our k, this is our a, and so forth, we can go with the assumption that this b is equal to 5. Okay, now we got one more missing piece of information. We need c. Well, we got our formula. Formula's on the right. B squared is equal to c squared minus a squared. B we said was 5, so we got 5 squared is equal to c squared minus a, which is 4 squared. So 25 is equal to c squared minus 16. Take that over, it becomes a positive 16. 41. So c is equal to square root of 41. Well, let's write down what we have. A is 4. B is 5. 5. C is square root of 41. H is something. negative 3, and k is 2. Negative 3? Yeah, negative 3. Okay. I don't even know what they were asking, to be honest. Find equation, then graph it. Okay, which formula is dealing with? We're dealing with the ones on the right. So, formula on the right looks like this. So we've got y minus k squared over a squared minus h minus x minus h squared over b squared equals 1. Okay, well, we no longer got our center at 0, 0. So we got y minus k. K was 2, so we've got y minus 2 squared over a squared minus x minus h. H was negative 3, so we've got x minus the negative 3 squared over b squared. So 5 squared equals 1. So we got y minus 2 squared over 16 minus x plus 3 squared over 25 is equal to 1. And that's our equation. Now, probably we can get by with the graphing part of it without finding any other information, but let's see. Our first vertex is negative 3, 6. Negative 3, 6. 1, 2, 3, 1, 2, 3, 4, 5, 6. So negative 3, 6 would be this right here. Our next one is negative 3, negative 2. So negative 3, negative 2 would be right here. So our vertex, our vertex. Our center is halfway in between those. So, what did I say? 6? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Right here would be our center. Our asymptote is going to pass through that. Obviously, our graph's going to open up and open down, like that. Asymptote was y minus 2. Oops. I thought I had to slide up there. Y minus 2 is equal to 4/5. X plus 3. I need to put that in slope-intercept form. Take 2 over. 4/5 times x is 4/5 x. 4/5 times 3 is 12/5. I take negative 2 over, it becomes a positive 2. So we got y is equal to 4/5 x plus 22/5, like that. Okay. 22/5. Boy, I'm going to have to get the calculator. I'm brain dead today. 22 divided by 5. What is that? 4.4. Okay. So this is y is equal to 4/5 x plus 4.4. Well, that's our y-intercept. So 1, 2, 3, 4, 4.4, I don't know, maybe about right there. Now, from there we're going to go up 4. 1, 2, 3, 4. So 1, 2, 3, 4, and right 5 would be somewhere right there. Now, I didn't need to do that because I know it goes through the center, but I just want to see how good a line I could draw. I know this other one by symmetry. I could do that, but I wonder if I can eyeball that. That's not bad. You know, by symmetry, what it's going to look like. You know, same distance from this point to here all the way across here should be the same as that. So our graph, don't know how soon it gets that close to the asymptote, but we'll pretend that this rough sketch I'm doing here is our graph. And that's probably as good as I'm going to get anyway, by hand, without plotting points and spending a lot of time on it, which don't plan to do that. Save this page. And let's look at our next problem. Now these last two, they want you to put them into standard form first. So let's take a look at that. We've got 9y squared minus 4x squared plus 18y plus 40x minus 127 equals 0. Now, it tells us to find a center, transverse axis, vertices, foci, and asymptotes, graph each equation. So do everything, basically. But we don't want to write this in standard form. I think it's the, let me just take a quick look here. I think it's the next lesson. We talk about the general form. Yeah, it is. The next lesson we talk about the general form of a conic. And this is taking it from general form and rewriting it in standard form. So what we want to do is our first step is group the x's, group the y's, and take the number to the right side. Number, I'm talking about the constant term. Now specifically we want the minus in between. So the I'm going to put the 9y squared here, and I'll put the 18y next to it. Then minus 4x squared plus 40x. And I'll take the negative 127 to the right side. And when I do that, it becomes a positive 127. Like that. Now sometimes you group it such that the minus is in the middle, like you see right here. And then at the very end, you flip them around anyway. But you just start out with that and see what happens. Step 2, factor out the number in front of the squareds. Well, the number in front of our y squared is a 9, so we'll factor out a 9, and that gives us y squared plus 2y. Number in front of our x squared is a negative 4, so we'll factor out a negative 4, and that gives us x squared minus 10x. Equals 127. Step 3, complete the square on the y's and on the x's. And I guess I'll do part of it here. For the y's, we take the number before our y, which is 2, and we multiply it times a half and we square it. It's always times a half, it's always squared. 2 times a half is 1, so we've got 1 squared or 1. Now for x's, we'll take the number before our x, which is negative 10, and we'll multiply it times a half and square it. It's always the numbers before your x or before your y, and it's always times a half and it's always squared. Well, that gives us negative 5 squared or 25. Now what we're going to do with these numbers, let's look at our y's. We came up with 1, didn't we? Inside the parentheses, we're going to add 1, and we're going to subtract 1. We'll come back to that. for the x's, we came up with 25. So we're going to, inside the parentheses, add 25 and subtract 25. Now we're going to think of this as one group, these first three terms here, and we'll think of this as a group. And we'll think of this as a group, and this as a group. So we're going to take these numbers that are in front, and we're going to multiply them times each group. So we'll take the 9 times the y squared plus 2y plus 1. And we'll take the 9 times the negative 1. This is still part of the completeness score process. We'll take the negative 4 times the x squared minus 10x plus 25. And we'll take the negative 4 times the negative 25. Now this y squared plus 2y plus 1 factors as y plus 1 squared. Now where that comes from is whatever number is right here in this parentheses, right before you square it, sign included, is what goes right here. 9 times negative 1 is negative 9. X squared minus 10x plus 25 factors as x minus 5 squared. Again, whatever numbers in the parentheses here right before you square it is always what goes right here, sign included. Negative 4 times negative 25 is 100. Equals 127. Still doing the completeness square part. We're going to take the numbers and move them to the right side. Well, when I take the 100 over, it becomes a negative 100. Take the negative 9 over, it becomes a positive 9. So that gives us 9 times y plus 1 squared minus 4 times x minus 5 squared equals 127 minus 100 is 27 plus 9, 36. Okay. We're just about there. Our fourth step is to get a 1 on the right side. Because remember, to be a hyperbola, you have to have a 1 on the right side. And well, you have to have some other things too. But so we're going to get a 1 there by dividing everything by that number. So we'll divide everything by 36. So I got 9 times y plus 1 squared over 36 minus 4 times x minus 5 squared over 36 equals 36 over 36. Well, this simplifies. 9 and 36 both divisible by 9. 9 divided by 9 is 1. 36 divided by 9 is 4. Minus 4 and 36 both divisible by 4. 4 divided by 4 is 1. 36 divided by 4 is 9. And 36 divided by 36 is 1. Well, now this is in standard form, more or less. Squared is on the y before the minus. So let's go look. Squared on the y before the minus. That'd be the one on the right side here. So we're dealing with the right formulas. And let's write this in the standard form first. So we got y plus 1 squared over this squared, which would be 2 squared, minus x minus 5 squared over, we'll rewrite 9 as 3 squared, equals 1. Dealing with formulas on the right side. So this is k, and its opposite sign. So k is going to be equal to a negative 1. This is our h, and its opposite sign, so h is 5. Now the reason why it's always opposite sign is because these are minuses here. When you have a minus up in your formula like that, it always flips the sign. And a would be this value, so a is 2, and this is b, so b is 3. Okay, well we got four of the items there. We just need to find c. Well, our formula says b squared is equal to c squared minus a squared. B we said was 3, so we got 3 squared is equal to c squared minus 2 squared. So 9 is equal to c squared minus 4. Bring the negative 4 over, it becomes a positive 4. That number looks familiar. C is equal to square root of 13. What if this is one? Hopefully it's not exactly like one we did before. Let me grab a pen. Where's the pen? And what did we say A was? A is 2. B is 3. C is square root of 13. H is 5. K is negative 1. Okay. Let's save this page. Oops. Okay, let's continue this problem. I don't remember what problem this was. 7? 7. Pretty sure we said formula on the right. It'd be wonderful to actually have a memory. It's funny. Some things like some things in math I'm just fantastic with. I can remember, but then other things I can't. Brain's a weird thing. It's right. Okay, and let's see. I said A was 2, B is 3, C is square root of 13, H is 5, and K is negative 1. So let's find our different items now. Okay, so our center is HK. So our center is HK, and we got 5, negative 1. 1, 2, 3, 4, 5, negative 1. Okay. And our transverse axis parallel to the y-axis. So parallel to the y-axis means, see if I can get it right this time. Look like that, and that means it'd be, I was going to do it again. X equals a number. And it'll always be the x part of your center. So our transverse axis is x equals 5. And the formula's on the right side, so foci. Our foci is hk plus c and hk minus c. H was 5, comma, k was negative 1, plus square root of 13, and then we'll have 5, negative 1 minus square root of 13. We don't use foci anyway. That's more of the for the definition of what is a hyperbola. Okay, our vertices. HK plus A and HK minus A. Well, H is 5. K is negative 1 plus A, which was 2. And here we'll have 5, negative 1 minus 2. Once we plug in our numbers. So this will be 5, 1. And this one will be 5, negative 3 for vertices. 5, 1. That'll be a vertex there. And then 5, negative 3. It'll be our center. 5, negative 3 would be right there. And, it's going to open like this. We said our transverse axis is x equals 5. So I know transverse axis looks like this. Okay, let's find our asymptotes. Formula on the right side, yeah. Okay. So our asymptote is y minus k is equal to plus or minus a over b x minus h. And I got my sheet here for what these are. What's k? K I said was -1. And it goes plus or minus a, which is 2, over b, which is 3, and then x minus h, and h was 5. Assuming I wrote those down right from the previous page. And so then I got plus or minus 2/3. Actually, let me just do the positive version. Make it a little bit easier. So I got 2/3 x minus 2/3 times 5 gives us 10/3. Take the 1 over. So we got 2/3 x minus 10/3 minus 1. 2/3 x, -3, -13/3. Which is y is equal to 2/3 x minus 13 divided by 3, 4.3. Now, if I looked at the negative version, it'd be y plus 1 is equal to, and I'm going to take the negative 2/3 multiplied through. So it would have negative 2/3 x, and negative 2/3 times a negative 5 gives us a positive 10/3. Take the 1 over. Oops, that should be an x. Okay. So we'll have negative 2/3 x plus 10/3 minus 1. Y is equal to negative 2/3 x plus 7/3. Like that. I'm not very good with decimals. I think it's 2 1/3, 2.3, but let me see. 7 divided by 3. 2.3. Though really, after you get one asymptote, you can probably, by symmetry, do the other one without doing this. So y is equal to 2/3 x minus 4.3. And y is equal to negative 2/3 x plus 2.3. Okay, negative 4.3. 1, 2, 3, 4. Negative 4.3 is somewhere right here. Up to right 3. Up to right 3 would be somewhere right here. You don't really need that second point. It's kind of a good check, because you know it has to go through the center. So if it doesn't go through the center, you know you screwed it up. There's an asymptote. Should have did that in a different color, but oh well. And since I already found the other one, 2.3 be right here. I know it has to go through the center, so I'm not gonna. So it looks like that. So our graph. Don't know when it starts skimming that, but we'll pretend that's close. And then it looks like that. Save that page. And let's look at our last problem. Actually, let me grab a drink first. Okay, so we got 9x squared minus y squared minus 72x minus 4y plus 131 equals 0. Okay, it's given us in general form of conic, and we got to write it into our standard form like we did before. Remember our steps. First step was to group the x's together. So I got 9x squared minus 72x. Group the y's together, so minus y squared minus 4y. And again, the minus should be between them like that. And take the number of the constant term to the right side. So take the 131 over. Now our step 2 was to factor out the number in front of our squareds. So in front of the x squared we have a 9, so let's factor that out. And that gives us x squared minus 8x. In front of the y's, I don't have anything there, but there's always that invisible 1, so we factor out a negative 1. And that gives us y squared plus 4y. Step 3 was to complete the square. So for our x's, take the numbers before x, which is negative 8. You multiply it times a half and you square it. Negative 8 times a half is negative 4. Negative 4 squared is 16. And we're going to both add that inside our parentheses and subtract it. So we have plus 16 minus 16. Now for our y's. Take the number for our y, which is 4. Multiply it times a half and square it. 4 times a half is 2. 2 squared gives us 4. And we'll not only add that inside, we'll subtract it. Now remember, we want to group these three terms together. The x squared minus 8x plus 16 and negative 16 by itself. And these three terms, y squared plus 4y plus 4 and the negative 4 by itself. We'll take the number that's in front and multiply it through each group. So we'll have 9 times x squared minus 8x plus 16 and 9 times negative 16. Negative 1 times y squared plus 4y plus 4 and negative 1 times negative 4. Well, this factors as x minus 4 squared. Again, whatever number's right here in the parentheses, right before you square it, sign included, so it goes right down here. Where's my calculator? $144. So 9 times negative 16 is negative 144. Now the negative 1, the 1 can drop away. And this factors as y plus 2 squared. Again, whatever number's right here, right before you squared, is what goes right here. Negative 1 times negative 4 is a positive 4. Well, then we want to take the numbers over to the right side. So I take the 4 over, take the negative 144 over. So we got 9 times x minus 4 squared minus y plus 2 squared equals negative 131 plus 144 minus 4. I'm doing my calculator so I don't screw it up right here at the end. I'm sure I probably got a couple of mistakes already in the video, but no need to intentionally put one there by screwing up some basic math. When you add those together, it gives you 9. And I don't remember what step we're on. I think it's step 4. Get a 1 on the right side, so we're going to divide everything by 9. So divide that by 9. And divide this one by 9. And then this one by 9. Now those cancel. So we got x minus 4 squared over 1 minus y plus 2 squared over 9 equals 1. Just about in perfect form. So rewrite this as x minus 4 squared. We want to rewrite the number on the bottom, something squared. Well, 1 squared. Minus y plus 2 squared. And this would become 3 squared equals 1. Okay. Squared is on the x before the minus. So squared is on the x before the minus. This is the formula on the left. And h is what goes with our x. It's opposite sign. So on this one, h would be 4. K is what goes with your y. It's opposite sign, which would be negative 2. This is our a. So a is 1. And this is our b, which is 3. Well, we need our c. So we got b squared is equal to c squared minus a squared. B we said was 3, so I got 3 squared is equal to c squared minus 1 squared. 9 is equal to c squared minus 1. So take negative 1 over, becomes a positive 1. So 10 is equal to c squared, or c is equal to the square root of 10. Okay, let me write these down so when I go to the next page I can retrieve them easily. There we go. So left formula, a is 1, b is 3, c is square root of 10, h is 4, and k is negative 2. Okay, we save this. And let's continue this problem. I think it's number 8. Okay, we got our left formula, and I said A was 1, B is 3, C is square root of 10, H is 4, and K is negative 2. Okay, working with the formula on the left. So let's find our center first, HK. Well, H is 4, K is negative 2. Four negative 2 would be right there. And our transverse axis. And it says, formula on the left, parallel to the x-axis. Okay, parallel to the x-axis. This would be y is equal to, I wonder if I screwed that up again. I'll write down the transverse axis. I'm not good writing down transverse axis. Okay, x equals, no, okay, that's correct. Never mind, just doubting myself. After I screwed that one up. I know this is the center. I know that it's a line going through that, so. So it means our graph would look like that. Opening left, opening right, and so forth. Okay, so our foci. Foci is h plus c, k, and h minus c, k. Well, h we said was 4, plus c, which is square root of 10, and k is negative 2. And this would be 4 minus square root of 10, negative 2. Our vertices, h plus a, k, and h minus a, k. So h plus a, k, and h minus a, k. H is 4 plus a. K is negative 2. And this will be 4 minus 1, negative 2. Which gives us 5, negative 2, and 3, negative 2. Oh, wow. Talk about screwing it up. There we go. Let's try that again. I didn't realize those were so close together. Try to make this a little bit bigger. 1, 2, 3, 4, 5, 6. Okay, center is 4, negative 2. So 4, negative 2 would be right there. And vertices 5, negative 2. That's still pretty close together. So that's our center, and that's our vertex. And 3, negative 2. Sometimes this happens when you make up numbers. But you'll get the idea, I think. Now our transverse axis, do yellow. I probably won't print it all. Oops, it won't even show on the screen. That's a nice color. Transverse axis, we know goes through that. And we know our graph's going to look like that. But we need our asymptotes to get somewhat of an idea. Deal with the formula on the left. So, formula on the left. So our asymptotes would be y minus k is equal to plus or minus b over a x minus h. Let me double check that. Sometimes my memory isn't what it should be. There you go. Okay, k, they're written on a piece of paper. What's k? K, y minus negative 2 equals plus or minus b, which is 3, over a, which was 1. Oh, that's nice. X minus h is 4. So that gives us y plus 2 is equal to plus or minus 3 times x minus 4. So y is equal to negative 2 plus or minus 3 times x minus 4. Let's split that up and look at our plus or minus version. So we've got y is equal to negative 2 plus 3 times x minus 4. And we got y is equal to negative 2 minus 3 times x minus 4. Well, that'd give us 3 times x is 3x. 3 times negative 4 is negative 12. Minus 2 is negative 14. That's not good. Negative 3x here. Negative 3 times negative 4 is 12. Minus 2 is 10. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. I know it passes through the center. There's no way I'm going to be able to do that. Not bad. And by symmetry, I'm going to try to guess the other one. There we go. Like that. By making these so I could try to see this a little bit better, I threw it way up there. Okay, and then it's going to skim that. It's going to skim that. And skim that. And skim that. And that'd be our graph. Assuming I didn't make a basic math error. Save that. And that's the end of that video. So let me stop the recorders.